Alright, in this tutorial we will talk about the class series, which is a one-dimensional array or simply a column in a table, as opposed of course to the data frame, which is basically two-dimensional usually, and it represents the whole table that consists of columns and rows. Okay, now first thing we are going to do in order to be able to use the series, which is a part of the Pandas library, is to import the Pandas library using the import statement in Python. So we start by saying import the name of the library, which is Pandas, and then we use an alias in order to easily refer to the library later on in our code. So we simply say import Pandas as PD. So later on we can just say PD, and that will automatically reference the Pandas library. Another library we are going to use in this demonstration is the NumPy library, and we gave it the alias MP. Now, let's start creating objects from the class series in order to represent that one-dimensional array or column. And there are mainly two ways, or in fact, there are so many ways to create series objects. But in this tutorial, we'll only focus on two ways. The first one using a Python list, and the other one is used by using a Python dictionary. So here, let's take an example where we have two lists. The first list consists of these values here, which are 13 in total, right? And two of the values are null values or empty values. We can reference that null value by using the nan object from the numpy library. So we simply say mp, the name of the alias, dot nan. And we did that twice to represent two null values in the list. The remaining values, as you can see, are simply integers. List 2 similarly has 10 values, 10 integer values in total. Now, let's create the first series object and store it in a variable named scores, for example. So we say scores is equal to PD, the name of the pandas library, dot series, right? And then we open a parentheses. It's exactly the same way we did when we created objects from the class car in the previous tutorial, right? We simply specify the name of the class from which we want to create an object. In this case, series. Since it's not built in, or we haven't built the class, and rather we imported it from a library, then we need to supersede the class name with the PD alias. Now we simply pass the Python list by doing like this, list 1, right? Now let's go ahead and print out the variable to see the form of the object. As you can see here, we have 13 items with indices or index numbers from 0 all the way to 12 with the values here. Okay. Now you might be wondering how did we manage to print out the object without using the print statement, and this is basically a feature of Jupyter Notebooks where we simply just reference or refer to the variable name in order to print its output, right? We can do it like this, the traditional way, and it would yield the same result. But throughout this demonstration and later demonstrations, we are going to simply refer to the variable names in order to print them out. Okay. Now let's apply the type function on this scores object just to confirm that the type of the object is actually a series. We say type of scores print, and as you can see, it's pandas.core.series.series. Okay. Let's create another object, another series object, and pass list2 as the input. So we say scores2 is equal to pd dot series, open up parentheses, and then pass list2. Now let's print out scores 2, and as we can see, we have 10 items or 10 rows in total in this series object. All right, now another way to create an object is using a dictionary where each index, or sorry, each key in the dictionary represents an index, and each corresponding value to that key is the value at or the data point at that row. So let's create the series and see its form. PD dot series, right? And then we pass dict. Now let's start inside the variable. Let's name it S3, for example. Go to a new line and print out S3. As you can see here, M1 is the key, oh sorry, the index, and 12 is the row value. M4 is the second index, and 222 is the row value. So each key represents the index, and each value represents the row value or data point. Go ahead and use the type function on this object just to confirm its type, the same way we did with these two objects here. All right, now we agreed that series is a class, right? That consists again from a list of attributes and methods. Now here we will go ahead and start referencing the different attributes to see the different data they hold, because attributes are nothing but data fields or variables that store some data about the object we are dealing with. Now, an important reference to always keep on your side is the official documentation of the library you are dealing with. And now, since we are dealing with the Pandas library, right, then we can use the official documentation of Pandas, right, and navigate to the series part. And from here, we can see a list of all the attributes supported for the series object. For example, array, attributes, access, dtype, all the way down. Additionally, we can see a list of all the methods supported for the series object. And all of these are methods supported. Okay, as you can see, we have tens of them here. Therefore, we can't memorize all the attributes and the methods. And that's when the documentation becomes helpful, because basically gives us all the attribute and method options along with descriptions and extended explanations of how and where to use them. So let's go through a bunch of attributes and see how they work. Let's do that in a separate cell for each attribute. So first attribute, what is the data type of the series rows? For that, there is an attribute called dtype. Okay, now let's go back to documentation and see the description of this attribute, dtype. It returns the dtype object of the underlying data. It basically tells us whether the data in the series is of the type integer, float, a string, boolean, or an object from some other class that we have created previously. So let's take this to the cell here and print it out by saying score.dtype. As you can see, the dtype is float 64, or simply float, right? Now, you might be wondering, why is the type float, although the values here are integers? It's simply because there are null values. So Python automatically will consider the data type to be float rather than integer. Okay. Another attribute is the index. So print out the series index. Let's go back to the documentation and see the index attribute. Index. The index of the series. Okay, so let's take this to this cell here and see. As you can see, it returned a range index object, okay, that starts from 0, stops at 13, and increase in steps of 1. So if we printed out the type of scores index, then it basically tells us that the object type is range index. Now, in order to extract the values in that object, then we need to loop through it through a certain loop mechanism. So let's try the for loop. For n index n scores.index. Go to a new line and print out index. As you can see here, we have all the index numbers from 0 all the way to 12, since we have 13 elements or 13 rows. Okay, great. Next, get the name of the series. The attribute for that is simply scores.name, right? Let's take a look at the documentation. And here we go. Name. Return the name of the series. So let's go back and use it here. And we get nothing. Why? Because the moment we create the object, there won't be any name assigned to that object until we give the object a name manually. So let's change the name of the series to scores. So let's take this part here, right? Apply it, okay, and then get the name of the series after it has been updated. So let's get the name one more time. As you can see, now the name has been changed to scores. Okay, next, get the size of the series. Scores.size can help us do that. And here we can confirm that this is the case. So it returns the number of elements in the underlying data. Is it a series of 12 elements, 15, 100 elements? So let's use this right here and we get 13. Keep in mind that we can easily print out this value, but we can also store it in a variable and then print out the variable, right? So we can say size of series, right, is equal to this size and then print out the variable. That will give us the same exact value. But let's keep using the shorthand version of this. Okay, next, print out all of the rows in the series as an array. All right, for that, we have a special attribute called values. So let's take a look here, values. It returns the series as ND array or ND like, depending on the type. Let's test it out. Here we go. It returned an array of all the elements in the series object. Now, you might be wondering what an array is. An array is simply a list, right? A list of some items of a particular data type, like integers, floats, booleans, strings, whatever. So array is very similar to a list, but it's a separate data type. Okay, so arrays are separate from lists, and in certain cases they are used for different purposes. Okay. Now we are done with the attributes part. Now let's move on to the methods part. And as we agreed, the methods within the context of class, right? Or simply functions within the context of a class are called methods, but they are very similar in structure, right? So a method is a function. A function is a method. Now, let's take a look at the first method we can access. Get the first 7 rows in the series using the function head. All right. Now, it would be more correct to say the method head rather than the function, right? So, first the scores dot to access the method head. And since it's a method or a function, then we need to pass an argument as input, right? We don't need to, but this function can take an input or an argument. So let's go to a new cell and call this function. As you can see, it retrieved the first 7 rows in that series. 1, 2, 3, 4, 5, 6, 7. Okay, now let's visit the documentation section of the head method in order to see how it actually works. So from here, we can hit Control F and search for the head function. So head, it returns the first n rows. We can uh, expand our knowledge of this method by visiting its own web page. As you can see, series.head, it returns the first n rows. The function returns the first n rows for the object based on position. It's useful for quickly testing if your object has the right type of data in it. Okay. Second, we have the parameters. It accepts one parameter, n, which is supposed to be of integer value. The default is 5, meaning that if we didn't provide a value, then 5 will be taken as the input. Now, what does this parameter represent? It represents the number of rows to select. So if we set head of 10, it will retrieve the first 10 rows. Okay. Finally, it returns part. It tells you what type of object will be produced or returned by the method once we call it on the object. So it will be the same type as the caller. So if we called it on a series, then the output or the returned object will be a series. If we called it on a data frame, then it will be returned, a data frame will be returned, and so on and so forth. Okay. Now, one very important point to know is that for each method, okay, in the documentation, we have 3 main sections. The first section is the description of the method, or simply what it does. Okay. The second section is the parameters, or what are the parameters that this method accepts, keeping in mind that changing these parameters will slightly change the behavior of the method. Okay, it will normally return the same output, but these parameters will again slightly change the behavior. And finally, we have the returns section, which is important to know what is the data type or simply type of the object returned by this method. This will help us in figuring out what type of other methods or attributes to apply on the returned object. So let's assume that this method returned a dictionary for us, right? Then in that case, we know that the returned object is a dictionary. So we can use the methods and the attributes specific to dictionaries. Okay, so again, three main sections to always look for in the documentation of any method: the description of what the method does, the parameters this method accepts, and the type of object returned by this method. Okay. Also, you can find examples of how this method can be used. Okay, for example, here we have one example here, another here, and so on. So as you can see, the documentation is a very helpful resource to guide us through the process of project development. All right, next, get the last 4 rows in the series using the function tail. So let's take a look at the function tail. Go here and search for this function tail. It returns the last n rows. So basically it performs in a very similar manner to the head method, but it takes or it retrieves the last n rows. So the last 5 or the last 6 or the last 7. Here's a description. Here are the parameters. And here's the return section along with some examples. All right, so let's test this function out, tail of 4, and it returned the last 4 values here. Okay, now next, get the count of non-null rows in the series using the function count. All right, so let's further investigate the function count. Count. There you go. Count. It returns the number of non-NA or non-null observations in the series. There you go. Description, the parameters it takes, and the returns part. Okay. So let's test this out, and as you can see, it returned 11 because we have 13 values in the series. 2 of them are null or NA simply. So the count function only returns the non-null values and ignore the rest. All right, next, get the sum, mean, and median of the series elements. In this case, we will use the methods sum, mean, and median. All right, and we will follow the same exact process that we did with the previous methods. Sum, here you go. Description, parameters, okay, and returns. You see, in this case, for this method, we had multiple parameters to use, and each one of them affects the behavior in a certain way. So for level, if the axis is multi-index, countering the particular collapsing into a scalar. Min count, the required number of valid values to perform the operation, right? And so on. It returns basically a scalar or a series if level is specified. So scalar simply means a value, one value, right? Okay, let's test this one. Value sum is equal to scores.sum and run it. And this is the sum, 3,457. Let's do the same thing for the mean and the median, okay? And then use a print statement to print out all of the values. There we go, mean and median, run. We've got the sum, the mean, and the median. Right? It's as simple as that. Okay, let's move on to the next batch of methods. The first one, print out descriptive statistics of the series. By descriptive statistics, we simply mean the measures of central tendency, right? Like the mean, median, and mode. The measures of dispersion, like the variance and the standard deviation. And some distribution related statistics, like the percentiles. First, as always, since it's a very important step, let's take a look at the documentation specific to this method. Go here and describe. There you go. There you go. Describe. Generate descriptive statistics. Descriptors include those that summarize the central tendency, dispersion, and the shape of the dataset distribution. Of course, excluding non-values. We have some parameters here that you can test on your own. We have the returns part. See, it returns a series or a data frame. So let's apply this function, this method here, and see. As you can see, we've gotten a new series, right? Where the indexes are count, mean, std, min, all the way down. And the actual row values are these. Okay, so you can see how series can be used for some other purposes here. Let's confirm the type of this returned object by applying the type function. As you can see, the type is a series. Okay. All right, next, check which rows are null and which are not, then count the null values up. Okay, now for that, there is a function called isNull. So now let's see the behavior of this function. It simply returns a series, right, with the null values marked as true and false otherwise. Okay, let's take a look at this function as well. I know we have done it a lot, but that's just to indicate how important this process is, which is to review the documentation. As null, it detects missing values. Okay, here are some examples, as we can see. Now, To count the values up, we can apply the series method that is called sum. Okay, now if we applied the sum on a series of integer values, then it will sum the values up. But if we applied it on a series of Boolean values, then it will only count the true observations in that series. Okay, so we can say nulls is equal to this, and then say or print out nulls dot sum. There you go. 2. Now you can again visit documentation of the sum function to see its behavior on Boolean values to confirm our theory. Uh, Now here we did it in line, right? So rather than storing this series in a variable and then apply the sum function to it, we did that in one line, sorry. So we said scores dot is null. The returned value or object will have the sum method applied to it. Okay, now drop the null values from the original series. For that, we have a function called drop NA. Again, I'll leave it to you to review the documentation for this part, but let's apply the function simply. Now, you need to know that the drop NA function or method returns a copy of the series with the null values omitted or deleted, but it doesn't affect the original version. This is very important. And that's why we applied the method here and we stored the return series with the nulls omitted in the same variable. That will simply update the variable with the new series and therefore affect the original version here. Okay. Now let's apply this function. Here we go. And print scores out. As you can see, now we don't have any null values in our series. Okay, next, check which rows are duplicated, then count them up. For that, we have the duplicated method. Right, scores the duplicated, right? Let's print this out. Keeping in mind that Jupyter will only print out the last variable or value. Okay, so we have scores there and we have scores that duplicate. It will ignore the first and just print out the second. And here we have a series of Boolean values where true indicates the duplicated and false indicates the unduplicated values. So it seems that we have a true value at the value at the value with index 10. So let's take a look at the original list to make sure that this is the case. Here we go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we go, 410, right? So we have 410 here, we have 410 here. So this one, the second one, will be considered a duplicated observation. Let's go back. Okay, as we agreed, how can we get the number of true values in a Boolean series? By applying the sum method. Sum. There we go. We have only one duplicated value. Go back to our comments here. Drop the duplicate rows from the original series. All right, without creating a copy. No, we do want to create a copy and update the original. There we go. All right. So the method to use is drop duplicates. It's as simple as that. Let's test it out. There we go. Scores the drop duplicates. Let's see. As you can see, 410 has been omitted. Okay, awesome. Next, we will add, subtract, and divide and multiply the elements in scores with the elements in scores extra or scores 2 as we named it, and store the new series in a variable. We will name that variable added series. Okay, or subtract series or divide series or multiply series or whatever. Now, it's as you can see here, we can actually add two series together. Okay, so if we had a series of 20 elements and another series with also 20 elements, we can add each pair of values from both series to each other. Okay, but with the stipulation that both series have the exact same size, 20 here and 20 here. Also, the indices must match. The index numbers must match between both series. Now, one way to do the summation or subtraction or whatever operation is to use methods like the sum or subtract or multiply, like this. As you can see, we have the sum method, right? Another way is to simply use the usual operators that we used on the simpler values, right? Like plus, minus, backslash, and multiplication. Now, before we proceed to do that, we need to reset the index, and let's see why. Okay, let's take a look at the index numbers of the series at its current state. So 0, 1, 2, 4. So where is the 3? 4, 5, 6, 8. Where is 7? 8, 9, and 11. Where is 10? And then 12. So we have three missing values, and these basically were the duplicated and the null values. But after deleting those, pandas will keep the original index numbers for these observations or rows. All right. So to reset the index or reorder the indices in order, all right, we can use the method reset index. And in that case, we need to pass two arguments, m place true and drop true. M place true means to affect the original copy of the series rather than creating another copy of it, right? Drop true is another argument that must also be provided whenever we use the m place true argument. So let's go to a new line and reset the index. Index has been reset, right? Let's comment this out, and now let's print out scores and see the new index. As you can see now, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we are done. We now are left with 9 elements rather than 13 because we deleted 3. Okay, now let's add both series together. So we have scores and scores 2. We can print them out, scores 2. Or both series, right? Now, let's take this part, do the addition between the scores, and then print out the added series. And here is the added series, right? 211 for the first, with the first element here, but from the second list. All right, there's an element here, as you can see, with the index 0, which is 33. So 211 with 33 will be 244. 410 with the first element here is 16, and we have 426. Right? Let's do a subtraction, right? Can name it subseries, right? And change the operation to minus. Set subseries, print it out, and here we go. This is the subtracted series. This is the original scores. This is scores 2, and this is the subtracted series with some negative values in certain cases. I'll leave it to you to do multiplication and division to see the output you will get. All right, so that was our overview of the attributes and methods supported by the series object. The most important takeaway here is to realize the importance of the documentation in figuring out the attributes and the methods you can use on these objects. Also, the importance of the different sections specific to any method. These are the description, the parameters, and the returns part. Okay. Now, looking at theory alone won't go a long way, so you need to practice using the different methods and attributes just to get used to it and to prepare for future analyses. So that was it for today's tutorial. I hope it was informative, and I will see you in the next tutorial. Goodbye.